So let us find the limit of x ln x as x approaches 0 from positive side. Why we are taking x approaching 0 from positive side? Because ln x is only defined for the positive numbers. So we cannot take here only x approaches 0. So now if we substitute the limit directly, we will get 0 times negative infinity. This is an indeterminate form. But it is not of the form 0 upon 0 or plus or minus infinity divided by plus or minus infinity. So if we get is form of 0 over 0 or plus or minus infinity over plus or minus infinity, then we can use the L'Hospital's rule. But we are getting 0 times negative infinity. But we can rewrite this x ln x as ln x over 1 over x. Now here we can see that ln, if we substitute the limit directly, then ln of 0 is negative infinity and 1 over 0 is infinity. So now this is of negative infinity over infinity type of indeterminate form. So we can use the L'Hospital's rule. So now let us take a limit on both the sides. Now let us use the L'Hospital's rule. So derivative of ln x is 1 over x and derivative of 1 over x is minus 1 over x square. The limit is as x approaches 0 from right side. Now let us simplify this. So this is limit x approaches 0 from right side 1 over x times x square over minus 1. So x and x will be cancelled out. So we will have limit negative x as x approaches 0 from right side. So this is equal to 0. Now let us take the another example. Limit of x raised to 1 over x as x approaches infinity. So now if we substitute the limit directly, we are getting infinity raised to 0. This is also an indeterminate form. But it is also not of the form 0 upon 0 or plus or minus infinity over plus or minus infinity. So suppose that y is equal to x raised to 1 over x. So now let us take the natural log function on both the sides. So ln of y is equal to ln of x raised to 1 over x. Now we know that power will comes in front of the ln. So this is equal to 1 over x ln x. We can write this as ln x over x. Now let us take limit on both the sides. So limit of ln y as x approaches infinity is equal to limit of ln x over x as x approaches infinity. Now here if we substitute the limit directly, we can see that we will get infinity over infinity type of indeterminate form. So here we can use the L'Hospital's rule. So this is equal to limit derivative of ln x is 1 over x and derivative of x is just 1 as x approaches infinity. So this is equal to limit 1 over x approaches infinity. So this is equal to 0. Now we know that e raised to ln y is equal to y. So we want to find out this limit of x raised to 1 over x as x approaches infinity. So limit of x raised to 1 over x as x approaches infinity is equal to limit of y, because x raised to 1 over x is equal to y infinity. And we know that y is equal to e raised to ln y. So we can write here e raised to ln y as x approaches infinity. Now limit will go into the power of e. So this is equal to e raised to limit ln y as x approaches infinity. Now limit of ln y as x approaches infinity is 0. So this is equal to e raised to 0, and anything raised to 0 is just 1. So our limit x raised to 1 over x as x approaches infinity is 1.